discuss the concept of equilibrium as propounded by G.K. Gilbert, Grove Carl Gilbert. And he was also a contemporary of Davis. ये भी 1890s की बात हो रही है, G.K. Gilbert. But his concepts was very different from some of the Davis ideas. In fact, Davis is known to have borrowed Gilbert's ideas. So let me explain a bit of back logic also, then come back here. Ab dekho, essentially it's all about how do landforms develop. You can explain in terms of that they are the consequence of interacting factors. Okay, so there is erosion, there is deposition, there is upliftment, role of the rocks also. It's about the change in the slopes. So when you talk about a landform or a slope, in terms of the interacting factors, okay, all of them act together. This approach is what is called as the equilibrium approach, because here the landforms are seen as adjusting to the forces. Landforms as product of interacting factors. So erosion bhi hai, deposition bhi hai, upliftment bhi hai, rock hardness bhi hai, and all of them act together. The landform is a consequence of all of this taking together. It's something like the landform is adjusting. The other approach is there is one a dominant force, and this force is shaping. The shaping is consistent or continuous rather. The shaping is incessant. ये होता चला जा रहा है and is continuous in time. It starts from the youth, it ends at the base level. That the landforms are the consequence of one dominant force. Not too many interaction nahi hai. Ek force hai. Ek force, one agent. Okay, it is perhaps the rivers. The rivers are eroding and erodes. The eroding shapes the landform. The erosion is incessant, continuous chala ja raha hai. It is continuous in time. It starts from the high mountains youth or khatam hoga jakar base level pe. Okay, this is the Davisian idea. Now, in this, a very important point is, in this, the time is continuous, and the process, there are no rapid or sudden changes. Time is a continuous time, like background mein chal raha hai, and the processes, okay, there is no, then the processes, there are no rapid or sudden changes. So now, this is the Davis idea. The Davis idea में ये 2-3 words important है. One force, reverse, incessant and continuous, starts from this, ends at base level. ये 3 points important है. Now, when Davis was giving the theory, उसी time में Gilbert भी कुछ कहना चाह रहे हैं. Gilbert says कि no, this approach is not right. This approach is the cyclic time. This is a long duration time. Okay, this is cyclic time. This is not considering the interactions between different forces. It does not talk about the rock hardness, lithology. इसमें lithology का कोई role नहीं है. Okay, and Gilbert says कि नहीं, rocks also have some role to perform. In this, there is no role of endogenic forces. So if you're writing down, okay, Gilbert, you start from somewhere here. So I will now read out. Process approach is a part of the equilibrium approach. Difference ये है कि process में balance को obviously नहीं बोला जाता है. Okay, in equilibrium the balance is mentioned obviously. Ultimately, if processes do not operate, there will be no balance. Okay, it's only about how you're wording it. So all process theories are also actually equilibrium theories. But equilibrium theories अलग से हम बोलते हैं. Why? Because they stressed on that specifically. So Penck is also one type of equilibrium. Okay, so is Stoller is equilibrium. Okay, we have J.T. Hack also equilibrium. I'll come to that now. So now, equilibrium theory क्या है? There are many factors. Landforms का there is no final form. Okay, because process change होगा तो form change हो जाएगा. There is no final form in case of equilibrium. In Davis model, there is a final form called as the penny plane. इसमें कोई final form नहीं होता. Okay, in equilibrium, there can be changes. There can be changes in the nature and in the intensity of the forces and the processes. In the equilibrium theories, there can be change in the nature and the intensity of the forces and the processes. That's why isme kya hai? The changes are not always unidirectional and progressive. They're not always unidirectional and progressive. So in Davis model, you start with high height, ये progressively erode होके flat होके it becomes penny plane. ऐसा थोड़ी है कि erode हो रहा है, the mountain again starts rising. ऐसा तो नहीं होने वाला ना? Because Davis says there is no upliftment happening at all. So there is no change in the reverse direction. Erode होगा, it will fall down, it will become less relief, it will become flat and a penny plane. In this case, इससे ऐसा कुछ नहीं है. It's erosion going on, upliftment happens, landform can rise up now. It can rise suddenly, it can rise slowly. Then again, upliftment stops, erosion can be more. The landform again can come down, again can rise up. So there is no finality, there's no final form. The intensities can vary and the direction can also vary. It can be progressive, bhi ho sakta hai, nahi ho sakta, not necessarily. These ideas that Gilbert talked about first, these ideas actually came much later. But Gilbert was among the first persons to talk about equilibrium. Otherwise, in geomorphology, जो equilibrium approach hai, this became more popular during the mid and later 20th century. 1950s के बाद में they become more popular. In equilibrium theory, we are looking at process approach. In equilibrium theory, we are looking at control of rocks. Equilibrium theories, these are more about the local landscape. That's why they are more micro geomorphology. The equilibrium theories, Gilbert ने पहले कहा था, and this is going back to 1880s and 1890s की बात हो रही है. But as a major school of study, this happened in the late 20th century and the mid 20th century. 50s onwards development है. Like this man Stoller was writing in 70s and 80s की बात हो रही है. Okay, so this is also the process approach. Okay, this talks about the control of the rocks. It's about the local landforms and micro geomorphology. So what I'm looking at is that if they ask you a Penck question or a Davis question or LC King question, this can be part of your enrichment of the content. ठीक है, Davis ये बता रहे हैं, but there is a dynamic theory, equilibrium theory also. So let's get back to our textbook now. Let me give you the page एक बार, and then I will move on. I think I told you the page number yesterday. Yeah, page number 64. So Gilbert's understanding of time was quite different from the geologist's concept of time. In those times, basically Davis की बात हो रही है. According to him, geological time is rhythmic. It's not a continuous background, one direction नहीं है. Okay, there's day and there is night, there are seasons and there are dry conditions. The day ends, the day begins. It's rhythmic. It is an event of, okay. The motion of earth is rhythm. Okay. Gilbert differentiated the traditional concept of evolution. When Gilbert gave his theory, at that time, Darwin's model was known. Because Darwin's model came up in 1850s. Okay, and Gilbert is writing in 1880s. And evolution idea was taken by Davis. So यहाँ बता रहे हैं, but Gilbert is challenging that. He says, Gilbert attempted to differentiate the traditional concept of evolution from the non-evolution concept involving equilibrium model. Davis model is that concept of evolution. Gilbert's model is against of evolution. The evolution concept Davis ka tha, it was about continuous progressive change through time, and the concept of time, the dependent models him. Whereas Gilbert talks about a time independent model of a different kind. Okay, in dynamic equilibrium, he says the equilibrium concept is that every landform is a sum of the forces acting on the final form is equal to 0. In any landform, all forces act together, the net effect is 0. It's also called as principle of least effort, least force. Something like, okay, if this is a rock, there is something which is pushing the rock above. There's something that is pushing the rock down. You add up this will be 0. There is weight, there is erosion, and there is a landform. Agar 0 nahi hoga, the net effect will be, this will either go down if this is more, or this will go up if this is more. Okay, that's what he's talking about. This is called as the principle of least force. The forces are of two types. The driving force, ये जो नीचे से जा रहा है वो driving force, and the resisting force. Resisting force is the weight. Explain this model. I'll give you examples. Okay. He talks about formation of locoliths. Locolith volcanism. He says the formation, the rise of locolith or laccolith rather, depends on the competence of driving force. Driving force is the force pushing from below the magma, and the resisting force. The resisting force was the weight of the load on the top. The formation, the growth of laccolith continues so long as the driving force of magma is not countered. If the upliftment of magma is more, the laccolith will rise. If the weight is more than the magma, the laccolith will sink or will remain so. In other words, so long as driving force exceeds resisting force, the magma continues to rise upwards and the laccolith register continuous growth. The principle of least work is operative and some. Okay, fine. Is it okay, all of you here? So, आपको इसी का लिखना है summary. So, I started with what dynamic concept, what is equilibrium concept, how is it different from the ideas of Davis, and what is he saying? Okay, so 3 terms सीखा आपने. One is Gilbert is about rhythmic time. Gilbert लिख लो आप. What are the keywords क्या क्या हैं? Gilbert's ideas are about rhythmic time. मतलब time change होता है. It's not one continuous progressive time नहीं है. There is rhythmic time. Okay, then his concept is against the conventional concept of evolution. It is not same as the conventional concept of evolution. वो अलग है. Third thing, landforms are the product of equilibrium. Between what? Between the driving force and the resisting force. And the sum total of force is 0. That's his principle. The principle of least force. The sum total of the force is 0. The driving force is more powerful, the landforms will rise. The magma will rise. If the resisting force is more powerful, the landform won't rise. It sinks or remains like that. Okay? This is one part of equilibrium concept. अच्छा, डेविस ने एक और भी यूज किया था concept, the concept of grade imbalance. This is one concept. There is a second concept, concept of equilibrium in Gilbert's idea. First concept तो हो गया principle of a least force, which is essentially the sum of all forces acting is equal to 0. ये पहला वाला बता दिया मैंने. ये second concept है. The second is about the concept of grade of a river. ये भी एक type का balance है. The concept of grade of a river. What he's saying is that in the process of erosion, so we have got a mountain here, we have got the base level here. Okay, the river is moving, the river is eroding somewhere very far away. The river might deposit, the river is transporting. ये सब काम कर रहा है. He says this is how river moves. He says, सुन लो पहले. He says that in the process of this, there's one stage when the river is again in a balance or in equilibrium state. It's something like देखो जो river है, river का two type of activities हैं. One is the river has an erosion power and the river has transportation power. Okay, river can erode and the river can transport. If the sediments are such that the transportation के लिए enough नहीं है and the erosion power is more, the river will start cutting. If the amount that is, say energy is say E. For energy E, I need to have sediments S. Okay, with my energy E, I can transport S amount of sediments. But what if the sediments is less than S? So क्या होगा? Energy ज़्यादा हो गया मेरे पास में. The extra energy will start eroding the surface. It's like, I have got energy of 10 units और मुझे पढ़ाई करना है. अगर मेरे पास पढ़ाई के लिए उतना कंटेंट है नहीं, where I'm using maybe 5 units for पढ़ाई, बाकी 5 जो होगा वो distraction हो जाएगा. If I have 10 energy, I must use my 10 energy entirely for study. I hope you got the point here. But if पढ़ाई ज़्यादा हो जाएगा, my energy is 10, then I will fall tired and I will go to sleep. So a river performs like that. A river has energy called as E. Okay, and the E energy can transport S amount of sediments. If the sediments is less than S, if the energy E जो है, ये करेगा erode because ये extra energy इसके पास. But if sediments is more than S, the river can't carry. The river will deposit. but एक ऐसा balance condition है where the sediments it can transport is equal to exactly the energy. इसमें क्या होगा? The river will neither erode nor deposit. The river will only transport. So that is a type of a balance where the sediments are just equal to the transportation capacity of the river, in which the river will not erode, the river will not deposit. River will only transport. That is one type of a balance also. He called that as the state of grade of a river. Gilbert also talked about equilibrium. Talked about equilibrium in terms of grade of a river. A graded state is a special state when the energy of a river, Gilbert, no, not Davis, Gilbert, where the energy of the river is just right for the transportation of the sediments. In such a state, a river neither erodes nor deposits. The profile, the cross-section of the river valley, in such a state of balance, is called as the profile of equilibrium. It's called as the profile of equilibrium. Put a star mark. In this state, river neither erodes nor deposits, and there are no physical evidences of such a state. There is no physical evidence of such a state, but it is considered hypothetically possible. It is considered hypothetically or mathematically possible. It is like this. If I go by logic, a river is eroding and a river is depositing. It comes down, the erosion becomes less. Here, the deposition increases. एक टाइम ऐसे होगा ना जहां पर erosion is equal to deposition, as good as there is no erosion and there's no deposition. If I go by logical idea, it's like, I throw a ball above. It becomes slow, it becomes slow. For a fraction of a time, it is no velocity and then starts falling. So this point is a kind of a transition. So वैसे ही, erosion happening, becoming slow. Then the process of deposition starts. So एक जगह ऐसे होगा when this becomes zero and this has not started. That is erosion, deposition same and both are zero. So hypothetically हम बोलते हैं that this is possible. In reality, we have no evidence of this. Okay? Add a point. This concept of grade was also borrowed by Davis. This concept of grade was also borrowed by Davis. But the concept of grade was not compatible with Davis' idea. What I mean by this, watch here. Davis के case में erosion कब zero होगा? When will it become zero? It becomes base level, right? If a river is moving down the slope like this, when can the river stop eroding? At the base level. Is it possible यहाँ बीच में zero हो सकता है क्या? No. अगर zero होगा तो cycle रुक गया ना. So Davis says कि grade is possible, but we are saying इस case इनके case में grade possible लगता नहीं. It's a contradiction. Okay? Either you say base level is there or say there is grade. You can't have both together. Fine, all of you? So अगर पढ़ना है grade के बारे में, page number 389. When a river develops a course where the channel gradient is such that the flow velocity is able to transport entire load, the resultant longitudinal curve of the valley thalweg is called as graded curve, and the river after attaining graded curve is called graded river. The profile is called as the profile of equilibrium. There's balance between the transporting capacity and the total load to be transported. That's all. और इस curve में यहाँ पर कहीं पर आपका होगा the condition of grade. The shape of the curve will be open concave. Is it okay, all of you here? So यहाँ पर minimum erosion, यहाँ बढ़ेगा erosion and again become less. I'll move towards some kind of a balance. Now you understand this concept. Now watch. I'll go back to the question now. So now my question was discuss the concept of equilibrium of Gilbert. अब इसका structure कैसे होना चाहिए? Okay. First box is there are many approaches to landform study. There is a time-dependent Davis model, talks about only one dominant erosion process. And there is a dynamic equilibrium model that talks about लैंडफॉर्म्स एज द कॉन्सिक्वेंस ऑफ इंटरैक्टिंग। फिर आप एक डायग्राम बना सकते हो एंड गिव अ लिस्ट ऑफ व्हाट आर द एग्जांपल्स ऑफ सम ऑफ द डायनामिक थ्योरीज। So dynamic theories में गिलबर्ट आएगा। Dynamic theories में you also will have this man called J.T. Hack. Dynamic theory is also Schwamm's theory. Schwamm theory is also the theory of Stroller. 4-5 names: Gilbert's theory, J.T. Hack's theory. You'll not know everything, but ठीक है, इतना ही लिख डाल लीजिए। Schwamm theory. There is Stroller theory. Yes, yes, पेंग भी ऐड कर सकते हैं। Then you enter into that Gilbert's ideas of a dynamic equilibrium is based on the time, is not like what Davis said. He was against the idea of evolution, and he talks about the principle of least force. फिर आप समझा दो what is least force. There is a resistant force, there is a driving force. Example of laccolith. Explain this. Then you'll say there's another concept of equilibrium also of Gilbert, the concept of grade. One up answer, all of you. An introduction, a diagram schematic, what is Gilbert saying, examples through laccolith, what is he saying about grade, and the conclusion. Conclusion mein, what I told earlier, that the equilibrium is a more modern concept. Equilibrium concept became more popular 1950s onwards. Equilibrium concepts, they are more micro geomorphology. These concepts are more holistic. They reject the idea of historical approach and evolution. And Gilbert was the beginning of the concept. Is it okay? Question देखते ही ना पहले you should know the concept, इसलिए पढ़ा दिया आपको मैंने. Then you develop a structure. Your answer में अगर structure है, then your answer will be a smooth write-up. And I don't want a structure of more than 6-7 maximum boxes. Any questions on this? Anybody? Okay, fine. Let's move on. Next one is इसी से related है. I don't know if you have seen the question or not. देखो, I don't know what you feel about the preparation. Like I said, that it is your business to be in the process. Okay, मुश्किल लगे, आसान लगे. Okay, one of you met me, sir, time में कैसे manage करूं? मैंने कहा शुरू तो करो आप लोग. Ideally, okay, you can learn this. Okay, only when you do this. आपने पहले नहीं किया तो आप करेंगे. So my suggestion is घर जाकर ये पक्का question पढ़ो बैठ के. Read, think, apply, and then come back and discuss with me. Anyways, to the second day, so we'll give it up. If, now look at the question, if geomorphic cycle is accepted as valid, the penny plane is a necessary corollary to it. If geomorphic cycle is accepted as valid, the penny plane is a necessary corollary to it. मतलब अगर penny plane is an accepted theory, if क्या है वो, if cycle is an accepted theory कि हाँ ये सही है, तो penny plane होना ही होना है. अगर penny plane नहीं है, you can't have a cycle of erosion. Explain this concept. इसमें Davis model आएगा, yes, but पूरा explain नहीं करोगे ना बच्चे. You not write mechanically. Davis said this, Davis no. आप मुझे ये sentence समझाना है. अरे जब वो question बोला illustrate, right? मतलब क्या है? प्रूफ करो कि डिस्प्रूव करो? क्वेश्चन से इलस्ट्रेट का मतलब क्या है? I made a statement. You are a good boy. Illustrate. आप नो सर मैं मर्डर भी कर देता हूँ, कैसे मैं थप्पड़ भी मार देता हूँ, मैं चोरी भी कर भाई. Illustrate that you are a good boy, no? Yes, I am a good boy. Reason 1, I did this, I helped. Reason 2, I am sincere. Reason 2, I am whatever. Why will you go against it? हाँ होगा, वही समझाओ क्यों. और अगर पेनी प्लेन नहीं है, वो साइकिल कंसेप्ट हो ही नहीं सकता. वेरी गुड पॉइंट. पहला कि अगर साइकिल कंसेप्ट है, okay, there should be an end point. अगर cycle concept है, you must start from high energy, high velocity towards low velocity. तभी वो cycle बनेगा. Any cycle में अगर day है तो night है ना, अगर beginning है तो end होना ही पड़ेगा. And end का मतलब है you need something like penny plane. Okay, I hope you got the point here. और geomorphic cycle का important point ये है, there is no endogenic force acting. क्या मतलब क्या है? इरोजन होता रहेगा तो अल्टीमेटली कहीं तो खत्म होगा. यस, द बेस लेवल इज आल्सो इंपॉर्टेंट आइडिया. आपको ये समझाना, डू नॉट राइट द एंटायर डेविस थ्योरी, राइट व्हाट द टॉपिक आस्क्स. अब चैलेंज है कि टॉपिक समझना वो प्रॉब्लम हो रहा है कि क्या पूछना चाह रहा है. If Davis cycle is accepted as valid, then penny plane is a necessary corollary to it. Matlab, are there examples where the cycle is not right? Is it right or not? Is it possible cycle hota nahi hai? Examples hain ki nahi hai? Yes, Pink's model hai na, no cycle there. Equilibrium model, no cycle there. वहां बता देंगे, there's no penny plane required there. वहां बता देंगे, I don't need a flat final plane there. आपको यही समझाना है कि concept of cycle is like something like if there is a head, there must be a tail. If there is a day, there must be a night. I hope you got the point here. अगर कुछ घूम रहा है, it's bound to have a beginning and an end. It can again start, वो अलग बात है. But beginning के बाद में रुक जाएगा, वो नहीं हो सकता. It must logically go towards the end. Tell me that in the theory. So if geomorphic cycle is accepted as valid, the penny plane is a necessary corollary to it. So you must explain that the concept of cycle hai, this comes cycle. So what are the features of the cycle? And then say कि हर feature के लिए आपका penny plane होना जरूरी है. Feature 2 के लिए again penny plane होना जरूरी है. Feature 3 के लिए penny plane होना जरूरी है. And but there are examples which are not cyclic, okay, and we have no penny plane, no penny plane, no penny plane. ये पूछा ना, if it is accepted as valid, अगर ये सही है, then there must be a penny plane. Then we have to go for two parts. One will support, yes, because this question says if valid. Then I'll say yes, if valid, yes, but their examples not valid, and yes, penny plane nahi hai. So watch here. In a cycle, in the concept of Davis geomorphic cycle, key ideas kya tha? The key idea is that erosion is a gradual, continuous process because a river tries to meet the base level. Erosion is a continuous process because the river tries to meet the base level. Number 2, the erosion has an analogy of a youth to senile old age, where senile old age is represented by low relief, by a low altitude. There is decline in the absolute relief and decline in the relative relief. Third point, in the model of Davis, erosion, okay, is a repetitive. Erosion is like the only action. There is no upliftment. There is no crustal stability. There's no upliftment. There is no crustal stability. तो सोचो, देखो ना, कोई लैंडफॉर्म है, उसका कोई अपलिफ्टमेंट नहीं है, और आप उसको इरोड कर रहे हो, क्या होगा अल्टीमेटली? It must flatten into some surface near the base level, right? Okay. तो जरूरी है, I must have a penny plane. In Davis model, erosion is gradual. Okay, it happens continuously, and the river tries meeting the base level. Essentially, the driving force of the river is the difference of the elevation from the base level. भाई यहाँ पर माउंटेन है, यहाँ बेस लेवल है, ये डिफरेंस जो है यही तो रिवर को ड्राइव करता है. So if I meet the base level, there can be no erosion beyond that. Base level is the final level. So by this logic, penny plane as the final landform is a must. Please bear with this. ये कुछ काम चल रहा है, but I want to continue. Divya, the crustal upliftment was only for a very short time in the stage 0. It's not a part of the entire cycle. It happens before the cycle starts. You're forgetting that part. इतने कम time के लिए है, as good as he's ignoring upliftment. This one, that if you're moving from youth towards senile, ये जो condition है, no absolute relief. No relatively का मतलब क्या? It has to be a flat plane. There's a mountain. Okay. The gap is reducing and the height reducing. का मतलब क्या? ये ultimately flat ही बनेगा. You will have flat. There is no upliftment. Okay. This is unlike Gilbert's model. For Gilbert, there is the driving force. इसमें वो नहीं है. इसमें भी अगर erosion नहीं है, it's bound to have a final penny plane. Is it okay? The fourth point. Davis model of a cycle of erosion. Davis model of cycle of erosion is an example of closed systems. Is an example of closed systems. ये Davis ने कहा नहीं था, but we understand that. It's an example of closed systems. और closed systems में क्या है? There are two things. There is a finality of the last stage plus, okay, in the final state, it is going to be the state of zero energy and maximum entropy, maximum free energy. Davis model is an example of a closed system. In a closed system, there is a finality of a last stage. वो पक्का खत्म होगा. Closed system can't continue forever. It must end. और end तब करेगा when the energy is zero and when the free energy is maximum. We call that as entropy maximization. ये जब ही possible है in a landform when it is at the penny plane. अब बताओ ना, ये अगर sea level है, okay, where is the energy zero? A और B. अगर sea level ये है, energy zero कहाँ पर होगा? B में होगा, right? Okay, अगर closed system है, it has to come to the B, which is a penny plane, a flat surface near the basement. Is it okay? So why is Davis model, if possible, okay, it must have a penny plane? Why? Because ये 4 point बता दिया मैंने. One is it's a gradual process towards the base level. यही idea को last में मैं लिखा है in the terms of closed system. Second, there is a senile because Davis model का cycle जो है, it's replicating the idea of evolution. Okay, a body is born, somebody is growing and dying. Okay, तो end में आपका होने वाला है. Third, upliftment नहीं है. Okay, he has assumed the possibility of no upliftment, crustal stability. Okay, therefore you need, okay, a final one and this one. Now, having said this, in reality, much of the concept of a cycle is speculative generalizations. In reality, much of the cycle concept जो है, that is speculative generalization. Okay, there are disruptions. Okay, before a penny plane is formed. Okay, there are examples of, okay, rejuvenation before a penny plane is formed. The examples of, okay, penny plane itself getting uplifted, okay, which means there is no finality of a penny plane as the last stage. There's no finality of penny plane as the last stage. Okay, this was part of the non-cyclic theories and the dynamic theories. This was a part of the non-cyclic theories and the dynamic theories in landform development. In reality, most landform development is part of open systems process. Most of those are open systems process with many factors operating, and crustal stability is not guaranteed. And crustal stability is not guaranteed. आप सबको समझ में आया question, all of you now? You will not write entire Davis model. Remember this. ये question पूछ ही नहीं रहा है, ये कुछ और पूछ रहा है. So now think of how would you structure the answer? How do you structure the answer? So I would start probably by saying, okay, maybe 2 lines on what is a penny plane. It's a flat, it is monotonous, it is at the base level, there is no relief, okay, there is no elevations. The concept of penny plane was a Davis idea in its process of cycle of erosion. It's a stage-based model that talks about penny plane as the end product. What's a penny plane? Who gave the idea called penny plane? Okay, इसमें आप खत्म करो अपना introduction. Now you move on towards the following are the features of a cycle. Okay, that necessitates the presence of a penny plane. The following are the features of a cycle or the concept of geomorphic cycle that necessitates the presence of a penny plane. अब आप लिखो यहाँ पर 4 point. Okay, condition number 1, condition number 2, number 3, number 4. Therefore, if we consider a cycle concept as an important concept, penny plane development is a must, as above. However, ये एक हो गया. The next will be, however, okay, in reality, a cycle concept is not always valid, and therefore, a penny plane is also not a necessity. In reality, the cycle concept is not always valid. Again, therefore, the penny plane concept जो है वो भी हमेशा right नहीं है. Give us 2, 3 reasons now. Dynamic theory, upliftment ideas, the ideas of open systems, and conclusion. The cycle concept is a very interesting concept. There are examples of flat planes. There are examples of extensive, okay, monotonous relief near the sea level. The examples हैं हमारे पास. However, they are not necessarily the consequence of cycle and the finality of the cycle-based evolution. The penny plane can be uplifted, they can be submerged, okay, they can be structurally modified because in reality cycle does not operate. Okay, but हमारा cycle पे नहीं लिखना, आपको लिखना है penny plane पे लिखना है. How penny plane is important or not? Reality में हाँ ठीक है, we have got flat surfaces, but to say that the flat surface is always a consequence of a cycle कोई जरूरी नहीं है ना. The flat surfaces can be for whatever reasons. आप enrich करना चाहोगे, you can always add this idea of cycle was also taken up by L.C. King, and he also proposed something like penny plane, call that as a penny plane. आप कह सकते हो, ठीक है, fine. So both of them are cycle models and both talk about a flat surface eventually. Correct. I hope आपको question समझ में आया. ऐसे questions में even if you write not a very good answer, but question लग रहा है समझ में आ रहा, argument कर रहे हो, you get very good marks on this. Let's move on. Let me take up question number 5 because they are related है. There is uniform development of landforms in varying environmental conditions. There is uniform development of landforms in varying environmental conditions, and there is insignificant influence of climate change. There is insignificant influence of climate change in the development of fluvially originated landforms. There is insignificant influence of climate change in the development of fluvially originated landforms. Critique the statement. Can you tell me in one word or one, no, not one word, one phrase, one sentence, batao, what is the question asking you? Anybody? What is the question demanding out of the discussion? There is uniform development of landforms in varying environment, and there is an insignificant influence of climate change in the development of fluvially originated landforms. क्या मतलब बताओ? डेविस छोड़ो, मुझे इन जनरल बताओ ये सेंटेंस क्या कहना चाह रहा है. जोबनप्रीत, he is is saying different climates affect landforms. Explain with examples. Divya says, question क्या पूछ रहा है? Is a question telling us write about how climate impacts landform, or is it saying climate has no impact on landform? क्या है ये वाला? या ये पूछ रहा है कि क्लाइमेट का कोई इम्पैक्ट है ही नहीं. जो वनप्रीत आपने उल्टा कर दिया, एकदम फॉर्मूला वाला अटके गए हो. क्लाइमेट देखा, लैंडफॉर्म देखा, वही लिख के आ जाना है. यस राजदित्या, वेरी नाइस. चिराग, पढ़ नहीं रहे हो. द क्वेश्चन इज नॉट आस्किंग हाउ क्लाइमेट इम्पैक्ट्स. द क्वेश्चन आस्किंग क्लाइमेट हैज नो इम्पैक्ट. You are in a dry area, you are in a wet area, you are in cold areas, you are in probably warm areas. कुछ भी जगह हो, climate has no impact. There's insignificant impact of climate on pluvial landforms. मतलब क्या है? Wet area चले जाओ, delta बनेगा triangular. Cold area जाओ, delta बनेगा triangular. Okay, you go to hill area, plain area, कहीं भी चले जाओ, the river is always going to be V-shaped river. Okay, whether you are in high latitudes, low latitudes, cold conditions, wet conditions, अगर flat surface है, the river will meander. Okay, the climate change, climate variations does not have any impact. I hope you all got the point here. Okay, so what do you want? Can you agree with this or disagree with this? The question says critique the statement. का मतलब क्या है? Critique का मतलब क्या होता है? Critique is no. Critique means objectively बताओ, okay, with evidence, with examples, आपको क्या सही लगता है? Okay, it's like I am a movie critic. का मतलब क्या है? कि मैं मूवी देखूंगा और मैं सही बता दूंगा. अच्छा है तो अच्छा बताऊंगा, बुरा है तो बुरा बता दूंगा. I am not a fan types and I am not always a cynical mind. So critique is a very scientific evaluation based on objective examples and analysis. So the statement is right, yes, 1, 2 examples, but the examples where ये right नहीं भी है. आपको लिखना दोनों है, but question पूछ रहा है essentially about does climate impact landforms or not? The statement says no. अब बताओ सही है या नहीं. Is it okay all of you here? अब आप बताएंगे कि there are many factors that impact landform development. All the denudation processes, weathering हो, erosion है, deposition है, the role of rivers हैं, the role of glaciers हैं, they essentially are the consequence of atmosphere's interaction with the land, where climate has a very important role to play. We have got your exfoliation. ये सिर्फ होगा hot conditions में. We have got frost action only in the periglacial conditions. We have got very fine depositions only in the wet conditions. We'll have chemical reactions where in the moist and warm conditions. So reality में climate plays a very important role. Okay, there are climate, okay, typical climate landforms. We call those as diagnostic landforms. कि wet area का typical होगा, cold area का typical होगा. This is the school of climatic geomorphology. The statement says ये गलत है. In reality, climate change has no impact. This is the school of climatic uniformitarianism. Okay, that the same type of landform is formed, okay, in any type of climate. The landforms formed in one climate are also the landforms formed in another climate. Okay, इसका example किताब बताता है as tors, T-O-R-S. Tors are landforms. You can find them in the deserts and also in the periglacial conditions of polar areas. Okay, so Elsie King says climate has no impact. Okay, but there are theories that say कि नहीं ऐसा नहीं है. Climate has an impact. अब समझ में आया question all of you here? You start the answer with what now? start the answer by saying no, climate has impact, or will you start answer by saying it has no impact? क्या बोलेंगे आप? In this question, climate, landform, yes, impact है. Climate, landform, no impact है. आप शुरू किससे करोगे? 1 से कि 2 से? Yes, because the statement is there's no impact. Start with this one. Yes, no impact. Give examples. Who said this? Why he said this? And then say, you know, this is an old idea. The new idea is it has impact. And then give something around how it has impact. Is it okay, all of you here? इसीलिए थोड़ा patiently question पढ़ें. Okay, आपने mechanically आपने देखा climate change, landforms, and you said I will write about how climate impacts landforms. Question तो पूरा उल्टा कह रहा है. The uniform development of landforms in varying conditions. कि आप कोई भी condition जाओ, the landforms are always uniform. Okay, and there is insignificant influence of climate change in the development of fluvially originated landforms. पहले बताओ, क्या ये सही है that in river systems there is no impact of climate? Give me examples of कैसे सही नहीं है. Give me examples of how the river action is not same in all climate. ज्यादा बारिश में meandering नहीं होगा, वो stream, okay, उसको बोलते हैं deranged हो जाएगा. River shifting हो सकता है. Yes, yes. In dry conditions, more likely for canyons and deep valleys, such as the Colorado canyons, the Grand Canyons. Correct. और बताओ, river fluvial बोल रहा है, hard rock नहीं, climate बोल रहा है. आप कैसे क्वेश्चन मिस करते हो? देखो, will all rivers, I mean ultimately if I all for the same, will rivers make delta? But will the delta be same for dry areas and wet areas? क्या difference होगा? Delta तो है, but dry areas will have coarse deposits. Okay, the deltas of wet regions will have fine deposits. ये difference है Indus delta में और Ganga delta. Yes, landforms will vary. Okay, wet areas, in wet areas, the stream channel का discharge ज़्यादा होगा. Then wetter areas, the same river may be broad river. Dry areas में the rivers can be smaller rivers. हाँ ठीक है, V shape है, but फिर open और close भी तो होता है. I hope you got the point here. To say that कुछ भी climate or river will make the same thing, not necessarily. River action in semi-arid areas will create pediments, will create bahadas, will create playa lakes. इतना सुना आप लोगों ने? ये wet में थोड़ी बनता है. In the wet areas, you will not have bahada or the playa lake formations. They always are in the semi-arid dry regions. So ऐसे बताना चाहता example कि ये सच में गलत है. Okay, so it's not that. Okay, and again, okay, the meandering, okay, is not a function of any flat plane. Meandering is more where there is coarse and erodible deposits. अगर hard rocks हैं, the areas will not have meandering, but dry conditions हैं and weather sediments हैं, the river can easily erode. So meandering is common, but it's not that हर climate में meandering हो जाएगा. Okay, और end करोगे. Along with climate, they can also have other type of factors. Lithology as a factor, slope as a factor, vegetation as a factor. Yes, Nidhi, absolutely. Sea level change can impact. Okay. Can we have sea level change because of climate change? Yes. So if I have a same river, same landscape, and rising sea level, the cycle will stop. If I have the same river, same landscape, the river has fallen, I will have rejuvenation. To say that climate har jagah same landforms is wrong. Is it okay, all of you? Okay. So you got the question now. Let me explain the structure of the answer. Again, आप अपने काम में फोकस करो. These distractions, God is testing you for your, okay, your commitment. The online students, there is a bit of noise here, okay, but we'll manage. We don't give up as easily. Okay. The question is, okay, so the structure of the answer kaise hoga? The structure is that there are debates about the role of climate in landform development. Landform development is very complex. There are many factors. Okay, climate is one of them. So, stone se shuru karo aap. You probably can have a diagram and a schematic. कि भाई landform development में, okay, factor ये, time is a factor, climate is a factor, rock is a factor, slope is a factor, that the sediments are a factor, humans. So give a schematic or different type of factors impacting a landform. Okay, then view one is that climate has no impact. This is also called as the school of climatic uniformitarianism. The school of uniformitarianism. This was supported by L.C. King. Yes, Nidhi, you can add, correct. L.C. King. So what this says is, irrespective of the climate, okay, the rivers will create deltas which are triangular. The rivers will have V-shape of valleys. The rivers will have meandering on a flat landscape. The rivers will have a high relief in youthful conditions. The rivers will have low relief in senile conditions near the base level. Climate kuch bhi ho, rivers will create delta, all other factors remaining constant, and the deltas will be triangular in shape. River valleys are always V-shaped valleys. Okay, the rivers will meander on flat landscapes. Okay, that there is high relief in the youthful stage. वो कहीं पर भी हो, अगर mountains है, river आ रहा है, they will make canyons, they will have waterfalls. Okay, and low relief in areas, okay, which are near the base level. Okay, climate does not have an impact on the type of, okay, landforms. Okay, and you can add a point here, okay, that this was also the Daviesian idea, okay, because of which he generalized the fluvial cycle for all types of climate. This was the basis of Daviesian idea, Davis theory, and he generalized, okay, the fluvial cycle for all types of climate. Okay, this is the view number one. Now you come towards the next one is the view number two. Climatic geomorphology, however, is disputed. Climatic geomorphology is, however, disputed. Climate is a very important element of denudation processes, weathering types, effectiveness of streams as erosion agents, and in the type of depositional features. For example, okay, deep valleys in dry conditions, river meandering more likely in dry conditions with soft unconsolidated sediments. Meandering more likely in dry conditions with soft unconsolidated sediments, जहां पे आराम से erosion हो सकता है. Deltas with coarse texture sediments in dry areas. Deltas with coarse texture sediments in the dry areas. And fine textured sediments in the wet areas. बता देना Ganga Delta versus Indus Delta. Rivers will form bahadas and playa lakes in semi-arid areas and arid regions. Rivers will form bahadas and playa lakes in semi-arid and arid landscape. In semi-arid and arid landscape. Okay? Next, the concept of climatic geomorphology, is extended to all other type of landforms and agents of denudation. Is extended to all other types of landforms and agents of denudation. There are diagnostic landforms. Typical to the climate types. जैसे कि pedestal rocks जो हैं वो सिर्फ बनेंगे deserts में. Pingo lakes only in case of periglacial. Yeah. Laterite formations in the wet, warm conditions. Yes. Examples of pediments also in dry conditions. We call those as diagnostic landforms. And the answer by saying landform developed in this climax process. अब वही idea को repeat कर देना. The many factors involved. Climate has a role. You can't dismiss. Finish it off. Again, I repeat. यही सवाल नहीं पूछेगा, लेकिन सवाल पूछ सकता है आपको. What are the factors of landform development? Okay. So factors of landform development में एक दो पैराग्राफ हो सकता है. The role of climate. और उसमें ये डाल देना. Okay. See, your answer has to be smart answers, rich answers. So you have to find conditions where you will apply. Limestone topography, wet areas में नहीं, उल्टा बोल दिया आपने. Limestone topography बनता है dry areas से बनता है. Wet areas में limestone will get washed away. Okay, you have got the answer. You want to read something about this? We have it in the page number chapter 4, page number 90. एक एक बार उल्टा लो उतना काफी है. You don't have to go too much into it. Diagnostic landforms, page number 90. Okay, or those who have done the class, fine. Otherwise, okay, you can think of using this diagram. Okay, where you have a rainfall and temperature. अलग-अलग condition में, oh yes, thank you. अलग condition में, what are the processes? Okay, so if it is high temperatures and dry conditions, very less moisture. Okay, a bit more rainfall. Okay, and moist conditions, chemical weathering. Okay, you have got good rainfall, high temperature, strong chemical weathering. So weathering, denudation depends on the conditions of climate. So ये diagram बना लेना, it'll help you. Or maybe you can talk about this also, river erosion. So this is the amount of temperature here, and this is the rainfall here. So when the rainfall is more, okay, and the temperature is here, you'll have the maximum fluvial erosion. Okay, so less rainfall, high temperatures less, and you have more rainfall, cold conditions again less. So this area, so it's also good diagram. Page number 93. Pick up any one of this you want to pick up. Okay, okay, let's move on. Question number 2, I think ये आपका state questions है. The theory of isostasy based on principle of buoyancy, the concept of equilibrium and isostatic adjustment. ये basically पूछ रहा है, write a note on Airy's theory. Airy's theory is principle of buoyancy. Okay, and the concept of equilibrium, the same balance. Okay, and this one means how does land get uplifted, how it sinks because of olivine flow. There's isostatic upliftment and subsidence, tectonics wala jo hai. Okay, you don't have to go into Pratt. Okay, don't go into other theories, just buoyancy dekha, equilibrium dekha. You have to write about Airy's theory. Okay, how a landform balances by flotation. Okay, this is not much to add here. Yeah, there's the buoyancy equilibrium. Yes, the equilibrium is balance. The balance maintained by the flotation. Okay, the balance maintained by the roots underneath. Okay, the ratio जो है ऊपर नीचे तक 1:8 or 9 जो भी है, is because of flotation. So the balance is maintained by flotation, as in Airy's theory. The lithosphere on the asthenosphere was the right idea. Yeah, this one was to get hold of these concepts. Okay. Question number 3. Structural and physiographic features of the circum-Pacific zone are fully as spectacular as the better known San Andreas and Alpine faults. Discuss. बताएंगे आप क्या पूछ रहा है इसमें? And why is it asking? क्या context होगा? The structural and the physiographic features of the circum-Pacific zone are as spectacular as those of the better known San Andreas and Alpine faults. क्या कहना चाह रहा है? It is not a note on circum-Pacific belt. The Pacific Ocean, collision boundaries, and it has earthquakes, and it has volcanism. There's mountain building. There is archipelago. There are trenches. वो ये नहीं पूछ रहा है. क्या पूछ रहा है बताओ? और क्या focus क्या है यहाँ पर? Yes, fine. That's okay. But can you rephrase the question for me? The questions ये बताओ. Yes, yes. But something else also. You're right on right lines. Yes. Similar and maybe more diverse. Okay, fine. Yes. Common features के बारे में लिखना है. Is asking that. Is asking right about the common feature. देखो, this is your assumptions. No, not similarity. Okay. Yes, Rajditya. It's something like. भाई आप कहते हो यूएस में इतने लोग हैं, इतना डाइवर्सिटी है. भाई इंडिया में तो उससे ज्यादा डाइवर्सिटी है. ये क्यों बोला जाएगा? Why will somebody say that? It's because a lot of people seem to praise US and ignore India. Okay? A lot of people say कि US में visible है, उनकी democracy. मतलब यार आप हमें ignore मत करो ना. Just because they write about it everywhere, that's just because उनका media in some ways काम करता है, because the world press is more English dominated, does not mean हमारे यहाँ पर democracy नहीं है. The question is saying कि जो land में दिखता है, okay, the San Andreas fault, California, San Francisco, San Jose, दिखता है, earthquakes are visible, they're documented, they're photographed. Alpine faults, by the way, Alpine faults में debate है, ये है कि Alpine faults कौन सा पूछ रहा है? Alpine fault of the Alps पूछ रहा है और कहीं और है? जो न्यूज में रहा Alpine fault was in New Zealand. एल्पाइन फॉल्ट जो एक्चुअली न्यूज में है वो स्पेक्टेकुलर वन न्यूजीलैंड में, राइट अक्रॉस सदर्न एल्प्स ऑफ साउथ आइलैंड ऑफ, इट्स अ मैसिव वन, वो क्रैक दिखता है, इज डॉक्यूमेंटेड, स्टडीड, earthquakes are seen, earthquakes are almost 8 रिक्टर स्केल पे है, but does not mean कि पैसिफिक ओशन मार्जिन दिखाई नहीं देता है, शायद वहां पर लोग कम रहते हैं, शायद वो पानी में छुप गया है, does not mean वहां पर स्पेक्टेकुलर नहीं है. Lot of things about the oceans we do not know are more spectacular than what we can see on the land. ये सवाल है. Is it okay? Okay. So essentially, the question is asking us, can you establish the fact that the Pacific Ocean, with all its diversity, is actually incredible, more than what we see and know on the land? फिर आप बताओगे, these are the features of the circum-Pacific belt. There are trenches, वहां ट्रेंच नहीं है, यहां पर वोल्केनिज्म है, वहां वोल्केनिज्म नहीं है. These areas have archipelago islands, वहां पर archipelagos नहीं है. यहां पर fold mountains हैं, Rockies mountains हैं, वहां पर mountains नहीं है. These areas also have cracks, they also have faults, वहां पर still faults हैं. Is it okay, all of you here? And the earthquakes along the circum-Pacific belt can be even more devastating compared to what we have otherwise in the San Francisco or Alpine faults. And then while doing that, आप explain भी करोगे that yes, the Alpine faults we know are examples of CC collision, but circum-Pacific belt में OO भी है, OC भी है. Okay, the example of San Andreas, example of a transform fault, okay, which is also on the ocean floors, but he cannot on the Pacific margins nahi hai, but we do have on the ridge systems, we do have on the moor systems. This is the question. They don't get fascinated by, yes, absolutely, the circum-Pacific belt has more than 80% of the world's volcanoes. It has some of the most devastating earthquakes. So don't tell me Alpine fault में बहुत ज़्यादा है, यहाँ तो बहुत ज़्यादा है यहाँ पर. So it is not a simple question on tell us the features of circum-Pacific belt. वो तो लिखोगे ही लिखोगे. The wording now matters. ठीक है? So let me help you structure the answer. So structuring the answer is that endogenic forces create second order landforms, and the endogenic forces create a great diversity. Many of those are not as obvious or as recorded. This सारा जो है is all about endogenic, right? The endogenic forces, they create second order landforms. They create great diversity जो obvious नहीं है या वो दिखता नहीं है. It's not as recorded. Okay. Some of the interesting ones are the San Andreas fault, which is in California. It is a transform fault. Okay, is responsible for many earthquakes and devastations, much recorded and discussed in the history. Okay, you can have a discussion on how it is a Juan de Fuca plate, moving northwestwards. वो बना देना, diagram बना के दिखा देना. Okay, this is the crack, this is here, okay, California, San Francisco, San Jose, and so on. It's a massive fault that we have. Similarly, we also have alpine faults. We also have alpine fault. तो ठीक है, पढ़ के आपको पता नहीं चलेगा कि कौन सा बोल रहे हैं, but आप Alps में लिख देते हैं. The Alps are spectacular. Alps have collision CC. The Alps has reverse faults. Actually, alpine fault पूछ रहा है The one in New Zealand पूछ रहा है. Why? Because ये news में था. So this is Auckland Peninsula, North Island, South Island. ये है boundary of Pacific and Indo-Austral plate. ये ऐसे जाता है fault. It goes like this. This is the mountain called as Southern Alps. This is the Indo-Austral plate. This is the Pacific plate. This is an example of part CC, sorry, OO collision, और कुछ part में OC भी है. There's some parts here, part of the continents भी है. But ठीक है, it's Indo-Austral plate and the Pacific plate. And these faults are responsible for, okay, more than 8 Richter scale earthquakes. Okay, responsible for the faults in the massive faults in the mountain. And go and say something there. Okay? Finish this in about half the page. You'll move then towards yes, there is tremendous diversity. Tremendous diversity hai. Okay, maybe one paragraph about San Andreas fault, one about this one fault. But khatam karna within half a page. Then move on towards saying, but however, circum-Pacific belt is more diverse. The events are more dramatic. The events are more catastrophic, unlike known anywhere else on the earth. Unlike known anywhere else on earth. ऐसा और कहीं नहीं दिखता है. It's a continuous belt. Okay, from East Pacific towards North Pacific towards West Pacific, goes right down up to the Tonga Islands, and it includes the New Zealand's alpine faults also. ये पूरा एक ही सिस्टम का पार्ट है. East Pacific, North America, यहाँ पर आपका South America, Northern Pacific, parts of Aleutian Islands, Japan, okay, the Philippines, and also New Zealand. Okay, the circum-Pacific belt has the impact of both OO collision and OC collision. Okay, so the spectacular features are trenches, are accretionary prisms, are the Cordillera Mountains, are the andesitic volcanism. Okay, they include the subduction Benioff zone earthquakes. I hope you know these terms, right? वहाँ trenches हैं, वहाँ पर accretionary prism है. They become the fold mountains like the Andes and the Rockies. Those areas will have andesitic eruptions. Okay, they will have subduction zones with Benioff zone earthquakes. There are marginal seas. Go on there. Okay, in fact, the San Andreas fault and the alpine faults of New Zealand are part of the circum-Pacific belt. They're both part of the circum-Pacific belt. Yes, more than 80% volcanoes are here. Talk about tsunami impacts. Tsunamis of Japan, tsunamis of Philippines. Okay, the Challenger Deep. Say, add whatever you can add. Some of the most powerful volcanic eruptions. Do-तीन नाम बता देना आप. If you know about Philippines का Pinatubo eruption, I hope you know this one. In the Philippines, we have Pinatubo eruption, Philippines में, और Tonga Islands में है. Tonga Ahaipai is considered as more powerful than Krakatau. This has erupted in 2021 and 2022. It's Tonga Haipai. Tonga eruption, that's enough. Now you talk about eruptions of Indonesian islands. Merapi eruption, if you know this. MERAPI. Huh? Semeru, yes. Do-तीन नाम भी गिरा देना recent times में. We have the eruptions of St. Helens Mountains of North America. Okay. Conclusion is The plate interactions are everywhere spectacular. The plate interactions are everywhere spectacular. Many of which are not visible because they are on the ocean floors. Many of those not visible because they are on the ocean floors. The oceans have far more diversity than the continents. Hence, the ocean floor mapping was key to understanding the dynamism of the lithosphere. The ocean floor mapping was key to understanding the dynamism of the lithosphere and of the origin and evolution of continents and oceans. Origin and evolution of continents and oceans. देखो, my whole agenda is not to teach a new concept to you guys. जहां पर होगा करेंगे, but at least I'm forcing you to think on these lines. This is what we call as applied answers. Applied answers की पढ़ा है, again some heads, आप खींच के ला के डाल रहे हो in what is asked. For that, you must remember all the concepts पहले. Otherwise, you can't do this. But how can I be sure about that? He's asking me, ऐसे कितने सवाल आते हैं? Okay, आप mapping करो. Now I know L2, L3 are approximately 30, 40, 50% of your paper. And these are the ones that boost your marks. आपको चाहिए 280, 290 चाहिए. Okay, यही questions will push your marks up. Okay, let's move on. No worries. The variations with time of the geomagnetic field, the secular variations, are the basis of science of paleomagnetism. The variations with time of the magnetic field and the secular variations are the basis of the science of paleomagnetism. Discuss. क्या कहना चाह रहा है बताओ? That there are variations. One, number two, there are secular variations. What's the meaning of secular variations? Uniform variations, the same variations. हर जगह वही है. They are secular variations. And they are the basis of science of paleomagnetism. Discuss. Yes. तो ये क्वेश्चन क्या पूछ रहा है? What's the question asking? Okay, fine. Give me in one sentence, what is the question asking? You to answer part hoga, yes. The reverse of polarity is there, igneous rocks. Okay, I agree. वो तो आप लिखोगे. मैं पूछूंगा कि बताओ, describe a house to me. You can't say window. हाँ, वो तो window है, मुझे पता है, house में है. But house describe करो ना. House is a place where you live, it has walls and a roof, okay, with rooms where people share. फिर आप बोलोगे उसमें windows भी है, उसमें driveway भी होगा शायद, उसमें कोई garden भी होगा शायद. वो तो components है. This answer में you will write about reversal, yes. You'll talk about igneous rocks, yes. You'll talk about Curie point, yes. There are anomalies, yes. वो तो लिखोगे आप. Question पूछ क्या रहा है पहले ये बताओ ना. What is the question asking? So, what is that? Yes, very nice. The question is about how does the change in Earth's magnetic field and the way it preserves in the rocks, that was the basis of paleomagnetism. अगर Earth का field change नहीं हो रहा होता, I would not have paleomagnetism as the evidence for studying geomorphology. And not just that, change हर जगह same हो रहा है. If it is not south, okay, it's not south for every place on the earth. If it is strong poles, it is strong poles at everywhere in the earth. The dip angle is equal latitudes, it is dip angle latitudes everywhere on the earth. जब भी तो जो deviations होगा, हम बोलेंगे अरे ये तो anomaly है, ये anomaly कैसे हुआ? Okay, I know everywhere north is here, south is here, and I find a rock जिसका कि north उधर है, south इधर है. The change is secular. हर जगह same होना चाहिए. But I find a rock has an anomaly. What do I do then? I said, oh, this is because the earth has drifted and it has turned. Is it okay, all of you? Imagine if there was north-south polarity और हर जगह अलग-अलग होता, कहीं यहाँ पर ऐसे है, कहीं ऐसे है, I would have no study of paramagnetism in that case. So the fact that the Earth's field has changed at some frequency and time, and the change was same everywhere, and therefore when the rocks preserve the change and there are anomalies, tells us something about the crust dynamism, and that becomes the basis of paleomagnetic studies. Okay, Vidhu, you are fairly close to what I'm telling you. Fine, taken. Is it okay, all of you here? So before I give the structure to you, देखो, paleomagnetism जो है is essentially the magnetism properties preserved in the mafic, preserved in the basaltic rocks. Okay, this is the basis of the science of paleomagnetism. Okay, and the conclusions we draw, they are based on the anomalies. Okay, paleomagnetism जो है is essentially about what? It's about the magnetic properties preserved in the mafic and the basaltic rocks. These are rocks which are capable of getting magnetized. उसमें preserve हो गया. Okay, and when I find that there are anomalies, okay, the declination not matching, the dip angles are different, the intensities are different, okay, then I know there's something odd from what I'm expecting. That is the fundamental principle of paleomagnetism. Okay. This was possible because Earth's field is known to change. Known to change, there are variations. There are variations in the intensity. और जो variation होगा, this is everywhere. वो कनाडा में भी होगा, वो इंडिया में भी होगा variations, न्यूजीलैंड में भी होगा variations, everywhere. There are variations, but the variations are same everywhere. That's an example of a secular variations. There are examples of magnetic reversals or a reversal का impact everywhere. Okay, north-south reversal impacts all locations. It's everywhere. Okay? So the science of paleomagnetism is about recording the variations and studying the anomalies. It's about recording the variations and studying anomalies. Okay, because the variation patterns are same everywhere. Because variation patterns are same everywhere. Okay, now you'll move on towards one example. So number one is, say, the secular part क्या है? Secular part is that the dip angle is preserved in the rocks, and that is same as the latitude of the place. ये हर जगह वही rule है. The dip angle of the field gets preserved in the rocks, and it is same as the latitude of the place. Any anomalies on this implies there is crustal movement. The rocks must have been displaced. Any anomalies in the dip angle means, okay, because dip angle का जो property वो हर जगह same होगा. Any anomalies are indicative of crustal movement and the fact that the rocks have moved from their positions. That's one example. Second example, okay, the secular changes associated with the reversal of the magnetic field. Okay, so ये पूरे बैंड में ये नॉर्थ है, ये साउथ है, ये पूरे बैंड में ये साउथ है, ये नॉर्थ है. Okay, you are here anywhere you are there. अगर this is 70 million years old, anywhere the rock 70 million years old, ऊपर north होगा, नीचे south होगा, because there's only one north-south polar field. Okay, so the secular changes in the reversal of the magnetic field. Okay, for a given time, okay, the magnetic orientation is same at all locations. For a given time, the magnetic orientations are same at all locations. This became the basis of understanding sea floor spreading. Understanding sea floor spreading that had bands of reversed polarity rocks. That had bands of reversed polarity rocks. So I hope you know the diagram. Okay, there is Matuyama, a reversal. Okay, there is Gauss, normal. There is Gilbert, reversal. Bruce, I hope you know that. You can refer to that. Wait, I'll give you the page number. Page number 191. यही तो preserve हो रहा है. Bruns normal, Matuyama reversal, Gauss normal, Gilbert reversal. Bruns normal till around 0.5, 0.6 million years ago. Okay. Matuyama reversal till about 2.5 million years ago. Gauss normal around 3.5 million years ago. And around 4.5 is Gilbert reversal. So 4.5, 3.5, 2.5, 0.5. ऐसे याद रखो आप. And this gets preserved. These are variations in time. ठीक है? The next one, the third one. Third is the apparent polar wandering curves. So when they plotted, what they found was कि हर continent का जो curve of wandering है, वो अलग-अलग है. North America shows another type of wandering curve. South America shows another type of wandering curve. और ये possible नहीं होता, okay, because Earth always had one axis of polarity. So this type of variations का मतलब है something is wrong. Now we know because it is secular changes. So if you bring all the continents together, you find all the curves will overlap. You'll get a single curve. देखो आप, it is recorded that the polar wandering curves of every continent is different. The polar wandering curves of every continent is different. But in reality, whatever magnetic field variations we have had, in reality, whatever magnetic field variations we have had, are secular in nature. That is uniform at all locations. That is uniform at all locations. Hence, okay, it was logically reasoned that the continents all must have been together once. The continents must have all been together once. it is their drifting apart. It is that drifting apart that creates the variations in the polar wandering curve. Polar wandering curve. So if you take Earth here and North America, let us see how the poles have moved. It'll show a graph like this. If you go to Africa, let's see how the poles have moved. वो शायद graph ऐसे दिखाएगा. If you go to India, how has the poles moved? Maybe a graph like this. The fact is, if you bring them all together at some position, ये सारे lines मिल जाएंगे. Because we know कि जो भी changes हुआ होगा, it must have been same everywhere. ठीक है? So without this secular changes, I would not, because see, अगर बाकी में सबका अलग-अलग है, फिर तो I can't prove the continents are moving. It's only when I'll superimpose them at some position that I know कि अच्छा यहाँ से move क्या होगा. Is it okay, all of you here? It's like I mean a very simple example में, say this land shows North Pole is here. This one shows North Pole is here. This one shows North Pole is here. This is A, this is B, this is C. तो क्या हमारे पास अलग-अलग North Pole था क्या हमारे पास? मैं से no. ये सब इकट्ठा कर दो. A was here, maybe B was here, and maybe C was here. अब जब जोड़ देते हो, all the poles are combining. Is it okay, all of you here? If I see them separately, I am seeing that there are different poles. In reality, the changes are not like this. जो भी change होगा, सबका change एक साथ होना चाहिए. So bring them together. So A is here, okay, B is here, and C is here. ये यहाँ पहुँच गया है. This is what's happening in case of the polar wandering curve. So अगर changes same नहीं होता, this kind of pattern anomalies I would not have found. And the answer by saying, okay, the paleomagnetic studies are confirmatory of the continental drift process. The rocks are like tape recorders of the past magnetic history of Earth, okay, and hence the significance of such studies. That's all. So my assertion is, देखो, the regular answer आप लिखाएंगे. अगर question पूछा on paleomagnetism, add this idea somewhere in one paragraph. ये आ जाएगा as a part of significance of studying magnetic properties of rocks. Why is it possible to study infer? Is this answer. All fine, all of you? Okay, so I'm done with all the questions of today.